Special right triangles. So we're going to talk about two very specific types of right triangles before we get further into trigonometry, but we're going to be using our ideas of radicals that we have been practicing to find missing lengths of specific right triangles. So the first type of specific right triangle is a 45, 45, 90 degree triangle. So the side lengths of a 45, 45, 90 degree triangle are always x, x, and x root 2. Now pay very close attention to where all of them are. I always look at it as the side across from a specific angle. So across from both of the 45 degrees, or those congruent sides that make up the 90 degrees, are both the same length. So this is an isosceles triangle essentially. If you know one of those lengths, to find the hypotenuse, you multiply it by the square root of 2. So for instance, if this side was 3, then this side was 3, then this side was 3 root 2. So we could just put an x where all of those numbers are. So let's say that one of our side lengths was a 5. So if we look at our lovely triangle, and I want you to organize some of your work in a chart like this. It's especially going to come in handy when we have to deal with our square root. So across from this 45 degree angle is a 5. So on my chart, I'm going to say across from the 45 degree angle is a 5. Well, what that is telling me is that x equals 5. So wherever I see a 5 on all of my other parts of my table, I'm going to put a 5. I'm going to put a 5 where that x is, and I'm going to put a 5 where that x is, and that just happens to be with a root 2. So that means that the lengths of the sides of this triangle are 5, 5, and 5 root 2. So A is 5 and C is 5 root 2. Okay, let's try another one. Let's just say we are given this triangle. Across from the 90 on this triangle is 10 root 2. So across from, these are always across from 45s are the x's, across from the 90 is always the 10 root 2. Well, on this triangle, across from the 90 is, x root 2, is 10 root 2. What that tells us is that x is 10, because if you're matching it up, there's the root 2's, and then x must be 10, which means our two missing sides must both equal 10. So those are our two missing sides of our right triangle for a 45, 45, 90. Now let's say that we're looking for a 30, 60, 90 triangle. This one's a little bit different. Across from the 30 degrees, we consider it x. Across from the 60 degrees is x root 3. And across from the 90 is always 2x. So if you're given one of those sides, you can find all other sides of a 30, 60, 90 triangle. So I made this little table, and again, I want you to use this table to figure out some of these answers, especially because we're going to get a little bit more interesting than our 45, 45, 91. So across from the 30 is always an x, across from 60 is always x root 3, and across from 90 is always 2x. So if we look at our triangle that we have here, across from the 90 is 12. Okay, so this really becomes like an equation. So somehow 2x is the same as 12. So that's 2x equals 12. If I solve that, I get x equals 6. So I now know kind of like the key number to this triangle, and it is 6. So across from the 30 must be a side length of 6, and across from the 60 degree angle must be a 6 root 3. So this has a measure of 6, and this has a measure of 6 root 3. So I've found the missing sides of that triangle. Okay, let's say we have this triangle. So across from the 60 degrees is a 5. So I'm going to put that into my table right there. My table is just organizing my thought process. Now this is why it's important to have this thought process organized out. This right here is how we're going to find what the x value is, kind of that key number for this particular triangle. Because that is an equation of x root 3 is somehow a 5. So if I want to find my key value of x, and I want to get x alone, I need to divide both sides by the square root of 3. So x is now 5 over root 3. Now remembering that the grammar of math says that you cannot have a root in the denominator of a fraction. So I'm going to multiply the numerator and denominator by the square root of 3, and I'm going to get 5 root 3 over 3. So that's my x value, which means that across from the 30-degree angle is our 5 root 3 over 3. Across from the 90 is 2 times 5 root 3 over 3. So if I multiplied 2 over 1 times 5 root 3 over 3, I would get 10 root 3 over 3. So if I were to label this on my triangle, across from the 30 is my 5 root 3 over 3, and across from my 90 is my 10 root 3 over 3. So use your table of values to figure out what your x value is. You're going to be coming across an equation. Some of them are much quicker than others. Some of them are things like you're going to have to solve for x to actually figure it out. Do not forget to rationalize your denominators. Now, for last night's homework, I'm going to show you the answer key. Feel free to pause this at any point in time, and feel free to comment if you think I did a problem wrong, because you never know, that might have happened. So here is page 1. Feel free to pause it right now. And here is page 2. Again, feel free to pause it right now. Your homework is still due Friday morning by 5 a.m. Have a great day.